Hello everyone, welcome to yet another video of Smart Grid. So in today's video, we have, in the previous video, we have seen about the different types of distributed energy sources, and among which we have seen about solar cells in particular. So in these couple of videos, we are discussing more and more in detail about solar cells. So in the previous video, we have discussed about what is a solar cells, what are its importance, and what are the different types of solar cells we have. And we have discussed about only the emerging topics of solar cells because we were very much aware of the conventional solar cells. So next, in that we have discussed about plastic solar cells and organic solar cells. Now we will, in continuation we will see about how this plastic and organic solar cells work. So the basic principle is that it converts, any solar cells will convert sunlight into electricity. That is why it is called as solar cells or photovoltaic cells. So photovoltaic, photo means the bundle of energies, which is nothing but the photons. That is being converted into voltages, or you can say it as power. So that is why it is named as photovoltaic cells. So here also it converts the sunlight into electricity. But how the process? That let's look into it. The sunlight excites the electrons. We have an organic layer of semiconductor materials, wherein which we have silicons, and we have the electrons. These electrons will absorb the sunlight from the sun and gets excited and moves to the excited state. And these excited electrons flow through the material to create the electric current. So we have valence electrons, and these valence electrons will grab the energy from the sun and gets excited and flow through the material to create the electric current. So that is how these solar cells work. And this structure is very similar to a typically donor-acceptor systems. That is, we use a polymer and a fullerene molecules. So the polymer will donate the electrons, and the fullerene molecules will accept it. So it is a typical donor acceptor systems. Now, why we need this plastic solar cells? Because they are lightweight, they are flexible substrates, and that is why they can be processed through roll-to-roll printing for cost-effective mass productions. So we can easily roll it, we can carry it everywhere, and we can make it fix on any type of surfaces. And that is why these type of solar cells are high in production, and also it is cost effective also. And the other advantages are the low cost productions. Because of its simpler manufacturing processes, it is very cost effective, and also it is very much perfect for wearable electronics. And because of these kind of innovations in the production of solar cells, there are more possibilities for power generations even from a single device. So next we'll look for the thin film solar cells. So previously we have seen about plastic solar cells. Now we will see about thin film solar cells. The plastic and organic solar cells are both are of same type. Plastic solar cells, the organic solar cells are a subset of plastic solar cells. So plastic solar cells are primarily made of polymers, whereas organic solar cells have a layer of organic compounds. So let's now get into thin film solar cells. What are thin film solar cells? So these are solar cells that use very thin layers, which are micrometer thick, of semiconductor material. So these kind of solar cells are highly flexible, lightweight, and can be. So these kind of solar cells are highly flexible and lightweight and efficient for large area applications. So the main types of these thin film solar cells are amorphous silicon type thin film solar cells, and cadmium telluride, copper indium gallium selenide, etc. So based on the type of material used for these solar cells, it has been classified into these types. Now let's see the basic working principle. So it has a thin layer of semiconducting materials that are deposited onto a substrate, which may be glass or plastic. So it absorbs the sunlight, create charge carriers, and generate electricity. So this is the thin film solar cells. So we have a glass substrate below which you have the conducting materials which are etched in a thin film. So it is like a process of etching. So you don't have a thick layer of semiconducting material, just a thin layer above which we have a glass coating, glass material, because the substrate will increase the grasping of more sunlight. So the glass or the plastic will enhance the sunlight absorbability, the possibility for sunlight to be absorbed more, and these substrate will allow the sunlight to flow through it, and hence the thin layers of semiconducting material will absorb it, and the electrons within it can get excited, and hence the current starts to flow. Now, how it is more advantageous? It is highly flexible because it can be applied to any flexible surfaces, just like your plastic solar cells, and it uses low materials. Yes, that is the main advantage of this thin film solar cells. As the name suggests, it is thin film, so you have a very thin layer of the semiconducting materials, and that is why it is very material cost is less. The production of these thin film solar cells, in the previous plastic solar cells, we have seen that the material cost is high. The semiconducting material used for the plastic solar cells is more, and hence the material cost is high. But for thin film solar cells, the material cost is low because only a small layer of the semiconducting material is being deposited on the substrate. So the low material it cost, and it is cost efficient. Now let's see the advantages. Just like your plastic solar cells, it is lightweight and flexible, and you have versatile applications, like it can be used on rooftops, facades, and even vehicles. So just like your conventional solar cells, these solar cells can be used on any surfaces, any places, rooftops and plain areas and all, and it provides the same efficient power. It is cost efficient because it is cheaper compared to the traditional silicon based solar cells, since it uses a thin film technology, and it is aesthetically pleasing. These thin film modules can be more visually attractive, blending seamlessly with the architectures, and hence these kind of solar cells can be used on rooftops where people who give more importance to aesthetics. The challenges are it has low efficiency. The typical power conversion ratio of these thin film solar cells are less compared to silicon solar cells, and also some materials like cadmium etc. are not eco-friendly. They have health concerns also. They are not environmentally good to the surroundings, and its degradation rate is faster compared to crystalline silicon, which are the conventional solar cells. So it degrades faster because it has only thin layer of the semiconductor material, so it may get degraded very easily, and it has limited scalability. Yeah, it cannot be used in wide manner just like your plastic solar cells, but it is a good replacement for your conventional solar cells, but it has limited scalability also. So in a conclusion, we have seen about plastic and organic solar cells and thin film solar cells that represent a promising frontier of renewable energy. Both have distinct advantages in terms of flexibility, cost, potential, power output, and scalability, but it has their challenges remains a bit contradictory, because one has a good lifespan, the other one has not. One is highly efficient, the other is not. So based on the application, we can choose the different types of solar cells. There are many ongoing researches in the conventional solar cells and the solar technologies which can break through the current limitations, paving way for more sustainable, efficient solar technologies. So the upcoming future, more amount of solar cells can be expected in every home, wherein which high power energy consumptions can be can be expected in terms of these solar technologies. So hope this video is very useful to you. I hope in this video we have seen about the major types of solar cell technologies and its advantages and challenges. So in the next video we will see about yet another new topic in smart grid. Thank you. Thanks for listening.